Welcome to this deep dive. We're absolutely thrilled to have you with us
I'm
today.
really glad you could join us.
Yeah. If you've been paying any attention to the tech world lately, you know that the final week of February 2026, specifically the 22nd through the 28th, was just a massive watershed moment for Microsoft AI.
Mm-hmm.
We are witnessing a definitive structural shift right now. We're moving completely away from those simple conversational chatbots we've gotten used to over the last few years,
Right.
and we're entering the era of fully autonomous, multi-step agents. And the wildest part, this isn't just a software update. This shift is being backed by brand new custom silicon and some very strict lockdown-level enterprise governance.
It truly is a structural transformation across the board. I mean, the developments that rolled out over just these few days illustrate a massive leap in how artificial intelligence actually operates within a corporate environment.
Yeah,
We aren't just talking about a new feature here and there. We're talking about a completely new foundational layer for enterprise work.
exactly. So the mission of our deep dive today is to distill this incredibly intense week of Microsoft updates. We've got a stack of sources spanning bleeding-edge research papers, major product launches, new infrastructure, and the safety guardrails being put in place to control it all.
It's a lot to cover.
It really is.
Yeah.
Our goal is to cut through the PR noise so you know exactly how the Microsoft ecosystem is evolving without getting bogged down. We're keeping things calm, clear, and credible.
Sounds like a plan.
Let's start right in the lab with the theoretical breakthroughs that are actually driving these new autonomous capabilities.
All
I
right.
was looking through a paper published globally on Archive on February 26th.
Mm-hmm.
The headline was the EMPO framework, coming from Microsoft Research Encased. What happened is researchers unveiled exploratory memory-enhanced policy optimization, or MPO, which uses detective-like memory and offline learning to prevent agents from getting stuck in repetitive loops.
Right, the infinite loops.
Yeah. And why this matters is it boosts performance in complex multi-step tasks by 128.6%, paving the way for truly autonomous enterprise agents.
And that 128.6% jump, that is a critical breakthrough because one of the biggest bottlenecks with AI agents historically is something we call exploration failure.
Right.
If you've ever watched an AI try to complete a complex task, you've probably seen it get trapped. It just tries the exact same failing action over and over again, completely unable to break out of the cycle.
Yeah, before MPO, the AI was basically acting like a brilliant but incredibly stubborn intern who would try the exact same wrong password 100 times in a row, hoping it would suddenly work.
That is a perfect analogy. MPO solves this stubbornness by giving the agent three distinct operational modes.
Okay.
First, it can act purely on its trained instinct. Second, it can actually pause and query a memory bank of its past experiences. And third, it uses offline learning to internalize those past mistakes and successes.
Wow.
The researchers even built in what they call a curiosity bonus, which literally rewards the AI mathematically for exploring novel, untried scenarios rather than repeating past failures.
So it actually stops, thinks about what went wrong, and tries a completely new approach.
Yeah. Exactly.
That makes total sense. But if MPO gives these agents a working memory, how do they actually interact with the daily software you and I use?
Right.
That seems to be exactly what this new CorpGN framework is trying to solve. Globally, on that very same day, February 26th, there was a headline on the Microsoft Research blog for the CorpGN framework for AI agents.
Mm-hmm.
What happened is Microsoft published a framework for training digital employees capable of handling continuous overlapping workplace tasks by directly automating graphical user interfaces, or GUIs.
Yeah.
And why it matters is this approach yields up to 3.5 times higher completion rates in multi-horizon task environments compared to baseline models.
Which is huge.
Right, 3.5 times higher completion rate sounds great in a sterile lab, but how does CorpGN handle an actual messy corporate desktop where applications freeze, notifications pop up, and you're juggling 10 tabs?
That's the exact problem CorpGN targets. If MPO is about memory, CorpGN is about real-world workflow simulation. Modern knowledge work is not a single, isolated task.
No, definitely not.
It is a continuous, overlapping mess of activities. To handle this, CorpGN utilizes what they call a multi-horizon task environment. It gives the AI hierarchical planning and isolated memory so it can actually operate Microsoft Office applications just by navigating the graphical user interface.
Wow.
It isn't just relying on back-end code. It's literally clicking buttons, dragging windows, and typing on the screen exactly like a human employee would, visually assessing the screen state as it goes.
Which is incredible to think about.
Yeah.
But it's not all smooth sailing, right?
Not at all.
Because the very next day, on February 27th globally, a piece went up on the Microsoft dev blogs. The headline was Multimodal Post-Training Diagnostics from Microsoft Engineering.
Right.
What happened was Microsoft engineer Aditya Chalapalli detailed production-scale failures in agent reinforcement learning, noting that standard algorithms break under real-world latency and scale.
Yeah.
And why this matters is it reveals that training AI on short-horizon tasks actually prunes its ability to handle long-horizon tasks, requiring entirely new engineering strategies for Copilot.
What's fascinating here is how Chalapalli's post connects our previous two stories. His diagnostics expose the harsh reality of moving these autonomous agents from the pristine lab environment of MSR into a production environment like Copilot.
Right, because Copilot is messy.
Exactly. An agent operating inside Copilot has to juggle tool orchestration, reasoning, content moderation, and multi-step execution all at once. We're talking about decision trajectories that range from 100 to over 2,000 tokens, spanning anywhere from 6 to 25 separate steps.
And what he found was that training AI on short-horizon tasks, like the quick, easy stuff, actually destroys its ability to handle long-horizon tasks.
Precisely. When engineers train these policies on short horizons, let's say a simple 6-step task, the model learns a highly compressed representation of problem solving. It learns to take shortcuts.
Okay.
This active compression prunes away the deeper, more complex behavioral modes needed to successfully navigate a 25-step task.
So, if I'm understanding this right, by teaching the AI to be really good at sprinting, it's essentially forgetting how to run a marathon.
That's spot on. It creates this dip and recover performance pattern that degrades overall reliability. And this is exactly why the memory features of the EMPO framework and the messy workflow simulations of Corpighian are so vital right now.
Right.
They aren't just cool research projects. They are direct, necessary engineering interventions to solve this exploration failure before these agents are rolled out to millions of enterprise desktops.
Okay, let's unpack this a bit further because we are moving aggressively from the lab into actual software platforms that are hitting developer machines right now.
Oh, we really are.
Over on the Microsoft Tech community, published globally across February 24th and 27th, we saw the headline for Microsoft Foundry unification and new models from Azure AI.
Yes.
What happened is Azure AI Studio was officially rebranded to Microsoft Foundry, simultaneously rolling out GPT Real-Time 1.5, GPT Audio 1.5, and GPT 5.3 codecs. And why it matters is GPT 5.3 codecs delivers 25% faster execution time for complex engineering tasks, while the real-time models enable low-latency voice capabilities starting at just $4 per 1 million input tokens.
The rebranding to Microsoft Foundry is a really interesting structural move. It consolidates all their agents, models, tooling, and evaluations under a single unified namespace. It simplifies the deployment pipeline for enterprise IT.
Makes it much cleaner.
Exactly. But you're right, the models themselves are the real story here. GPT 5.3 Codex is specifically engineered for these long-running, multi-step engineering tasks we were just talking about.
Yeah.
It brings robust computer use capabilities and boasts a 25% faster execution time for complex coding tasks compared to previous iterations.
And on the multimodal side, those real-time models are pushing boundaries too, enabling hands-free voice interaction for developers starting at just $4 per million tokens makes building new apps incredibly accessible.
Oh, totally.
Speaking of developers, when I read the GitHub blog and Microsoft Dev blogs globally on the 24th and 25th, my jaw kind of dropped.
How about?
The headline was GitHub Copilot CLI GA and VS 2026 February update. What happened is the terminal native GitHub Copilot CLI reached general availability with an autonomous autopilot mode, while Visual Studio 2026 added a WinForms expert agent and Copilot call stack analysis.
Right.
Why it matters is it drastically reduces developer context switching by embedding multi-step AI capabilities directly into the command line and IDE. We are literally giving the AI the steering wheel in the command line.
It is a massive structural shift for software engineering. Think about the traditional developer workflow. It's incredibly fragmented.
Yeah, jumping between windows.
Exactly. But with autopilot mode in the CLI, the agent can autonomously execute tools, run scripts, and fix environment errors right there in the terminal. And the very next day, the Visual Studio 2026 February update dropped, adding even more deep integration. They introduced a WinForms expert agent and that Copilot call stack analysis.
The call stack analysis stood out to me. Instead of a developer spending an hour figuring out why an app is hanging, Copilot just reviews the current stack the moment debugging stops and explains the exact loop or crash in plain English.
Yeah.
It's embedding agentic intelligence right where developers actually build and deploy.
Precisely. And the WinForms expert agent is essentially an expert reviewer sitting over your shoulder, advising on granular UI things like table layout, panel layouts, or code DOM serialization. It drastically reduces the context switching that kills developer productivity.
Which brings us to the ultimate question. How is Microsoft going to package and monetize all of this autonomous productivity?
Always the big question.
On February 27th, globally, outlets like Business Insider and the Microsoft tech community ran the headline, Microsoft 365 E7 Bundle and Agentic Copilot. What happened is Microsoft rolled out agentic features, allowing Copilot to directly edit Word docs and PowerPoint slides, alongside reports of the planned high-end E7 bundle. Why it matters is the rumored $99 per user per month. E7 tier signals a massive strategic shift to monetize autonomous agents above the traditional E5 enterprise layer.
This represents a fundamental change in Microsoft's SaaS business model. Up until now, Copilot has largely been an advisor. It drafts text you copy-paste, or it summarizes a meeting.
Right.
Now it's an active participant. In Word, it's directly manipulating the document. In PowerPoint, it can autonomously generate slides, refine layouts, and ensure everything matches corporate branding guidelines without you clicking a single format button.
And the rumored E7 bundle is the monetization engine for that. It reportedly includes a new orchestration platform called Agent 365. But the price tag is what caught my eye. $99 per user per month. That is a massive premium over the traditional E5 enterprise layer.
It is a steep premium, but Microsoft is betting that companies will pay it because they are no longer just buying software. They are essentially leasing digital employees. If Agent 365 can autonomously handle the busy work of a junior analyst, $99 a month is a bargain for a Fortune 500 company.
But all of these new autonomous agents, from the terminal autopilot to Word document editors, they require an unfathomable amount of computing power.
They do?
Which is why Satya Nadella's keynote at the Microsoft AI Tour globally on February 24th was so critical. The headline was, the Maia 200 AI Inference Chip for Microsoft Azure. What happened was Nadella officially launched Microsoft's second-generation in-house AI inference chip, boasting 140 billion transistors.
Right.
And why it matters is it delivers 35% superior performance per total cost of ownership, or TCO, compared to leading alternatives, specifically optimizing the GPT 5.2 and Copilot workloads.
The Maia 200 is a monumental piece of hardware engineering. Tacking 140 billion transistors onto a single chip allows for highly sophisticated on-chip architecture and memory bandwidth. It is designed from the ground up specifically for the parallel processing demands of large language models. The key metric Nadella highlighted was that 35% superior performance per TCO compared to leading alternatives.
So it's cheaper to run and faster to execute, specifically for their own workloads.
Exactly. This gives Microsoft total vertical integration. They control the silicon, the server racks, the cloud infrastructure, the foundational models, and the front-end Copilot software. It's a massive efficiency play.
But what's interesting is they aren't abandoning partner hardware at all.
No, not at all.
Because on February 27th, globally, on the Microsoft tech community, we saw the headline High-Performance Inference for DeepSeek from Microsoft Foundry and NVIDIA. What happened is Microsoft detailed a collaboration with NVIDIA using NVFP4 quantization to run the DeepSeek v3.2 Mixture of Experts model on Blackwell GPUs. Why it matters is this optimization reduces the model's memory footprint from 690 gigabytes to 415 gigabytes and achieves up to 2.5 times lower end-to-end latency. Quantization. That essentially means shrinking the math so the model takes up less space and memory without losing its smarts, right?
That's a great way to put it. When we talk about a mixture of experts model like DeepSeek, we're talking about a massive network where only specific subnetworks of experts are activated for any given prompt.
Okay.
It's highly capable but incredibly memory hungry. By using NVFP4 quantization on Blackwell, Microsoft shrank the computational precision required, which drops the memory footprint by a factor of 1.7.
Wow.
And crucially, this optimization achieves up to 2.5 times lower end-to-end latency. If we connect this to the bigger picture, you see Microsoft executing a brilliant dual strategy. They are fiercely controlling their own destiny with the in-house Maia 200 silicon for their proprietary Copilot workloads. But simultaneously, they are heavily optimizing wildly popular third-party models on partner hardware to ensure Azure remains the absolute best place to run any AI. This gives Microsoft absolute infrastructural dominance.
Whether you want Microsoft's models on Microsoft chips or DeepSeek's models on NVIDIA chips, Microsoft Azure is collecting the rent.
Exactly.
But with all this unprecedented power comes significant risk. If AI is acting autonomously in the developer terminal and directly editing corporate Word documents, how on earth is it being controlled?
It's a huge concern.
Just to be clear to you, our listener, we're simply reporting the facts regarding these security updates without taking any sides on corporate data policies.
Always.
Let's look at the headlines across Microsoft Source EMA and Cloud Wars globally on February 24th and 27th.
Yeah.
Cyber Pulse Report and Purview DLP for Copilot. What happened is Microsoft's latest telemetry shows 80% of Fortune 500s deploy AI agents, but 29% of employees use unsanctioned ones. In response, Microsoft announced Purview Data Loss Prevention, or DLP, for Copilot. Why it matters is the new DLP system can proactively terminate Copilot responses or internal connections the millisecond a prompt triggers sensitive data flags. I have to ask, what does shadow AI actually look like inside a heavily regulated Fortune 500 company?
Shadow AI is a massive headache for chief information security officers right now. It happens when non-technical employees use intuitive low-code or no-code tools to build their own custom, unverified AI agents to automate their personal daily tasks.
Right.
A marketing manager might build an agent that scrapes internal sales databases to write weekly reports. The Cyber Pulse report, which surveyed over 1,700 data security leaders, revealed that while 80% of enterprises use agents, only 47% have dedicated security controls in place to monitor them.
That is a terrifying blind spot for any company handling sensitive data, which explains Microsoft's immediate response on the 27th, announcing Purview DLP specifically for Copilot.
Right. The Purview DLP system acts as a hard boundary, an instantaneous kill switch. If an employee's custom, unsanctioned agent attempts to access restricted financial data, or if a prompt triggers a sensitive data flag, the DLP system proactively terminates the Copilot response and severs the internal connection the very millisecond it happens.
Wow.
It enforces strict corporate data boundaries across the entire Copilot estate, regardless of who built the agent.
So that addresses the data security side of the equation. But what about the actual quality of the work these agents are producing? There's a fascinating, almost contradictory narrative happening at the very top of Microsoft right now.
There really is.
Globally, on February 23rd and 25th, the Register ran the headline, AI Output Reliability and Developer Labor from Microsoft Leadership and Research. What happened is CEO Satya Nadella stated on stage that nobody wants anything that is sloppy from AI, coinciding with a paper from Azure CTO Mark Russinovich warning that AI agents impose a drag on junior developers.
Yeah.
Why this matters is it highlights an internal recognition at the highest levels that unverified AI output carries massive operational risks, requiring senior engineers to mentor juniors to fix agent mistakes. So wait, we're rolling out autonomous control to the command line and charging $99 a month for it. But at the same time, top leadership is publishing papers admitting the AI makes sloppy intern-level mistakes. Isn't that a massive contradiction?
It is a fascinating tension, and it touches on the absolute most critical human element of this AI adoption wave. Rusinovich's paper, titled Redefining the Engineering Profession for AI, argues that while these agents provide a massive productivity boost to senior engineers who know exactly what to ask for, the AI models frequently exhibit what they literally call intern-like behaviors.
Right? They write code that looks correct, but contains subtle structural flaws.
And that creates a nightmare for the junior developers.
Exactly. It creates a severe skills gap. Junior coders who haven't yet built the foundational intuition of how complex systems fit together are now being forced into roles where they have to steer, verify, and debug AI output rather than writing code from scratch. This creates the AI drag. Because the juniors can't catch the subtle hallucinations, senior engineers are being forced to spend their valuable time actively mentoring the juniors and double-checking the AI's work to catch these sloppy mistakes before they hit the production servers.
That makes a lot of sense.
It highlights a massive internal recognition that unverified AI output carries massive operational risks.
It's a stark reminder that humans absolutely must stay in the loose, even as the tech gets more autonomous. Here's where it gets really interesting, though.
Microsoft isn't just focusing on internal tech. They're actively securing their broader ecosystem through strategic alliances and highly specialized deployments. We have to talk about the joint statement issued globally by Microsoft and OpenAI on February 27th and 28th, covered by ITEA and MLQ.ai.
Yes.
The headline was Joint Statement on Core Partnership Resilience. What happened is Microsoft and OpenAI issued a joint statement to clarify their relationship, following OpenAI's massive $110 billion capital raise from external tech companies. Why it matters is it legally reassures enterprise clients that Azure remains the exclusive cloud infrastructure provider for stateless OpenAI APIs, preserving Microsoft's core AI revenue pipeline. The market was incredibly anxious because OpenAI just closed that $110 billion capital raise from external tech companies, including heavy hitters like Amazon, SoftBank, and NVIDIA.
The market was definitely looking for clarity. When a company as central to Microsoft's strategy as OpenAI takes $100 billion from Microsoft's direct cloud and hardware competitors, it naturally creates uncertainty. Analysts were questioning if Microsoft's exclusive access was in jeopardy. This joint statement was a strategic maneuver to calm those fears. It publicly confirms that the core partnership terms remain entirely unchanged.
And the specific phrasing they used was very deliberate. It legally reassures enterprise clients that Azure remains the exclusive cloud infrastructure provider for stateless OpenAI APIs. When they say stateless, in plain English, that essentially means the AI doesn't retain any memory of the prompts or data you feed it, keeping enterprise corporate secrets completely safe from being used to train future models, right?
Exactly. A stateless API means your proprietary corporate data is processed and immediately discarded. It's the bedrock of enterprise AI trust.
Right.
By reaffirming that Azure is the sole provider for these secure, stateless API endpoints, Microsoft preserves its core AI revenue pipeline and reassures its biggest Fortune 500 clients that their data governance terms are firmly locked in, regardless of who else is investing in OpenAI.
And for clients who need even more than a stateless API clients who need absolute physical isolation, Microsoft announced a new solution globally on February 24th on Microsoft Source EMEA. The headline was Foundry Local and Azure Local, disconnected from Microsoft's sovereign cloud. What happened is Microsoft enabled fully disconnected offline operations for Azure Local, Microsoft 365, and Foundry Local utilizing NVIDIA hardware.
Right.
And why it matters is it allows highly regulated organizations like governments and defense sectors to run massive multimodal AI inferencing entirely cut off from the global internet.
This is all about ultimate digital sovereignty. There are certain sectors, military, defense, intelligence, highly regulated national governments that simply cannot, by law, connect to the public global internet for compliance and security reasons.
They need an air-gapped system.
Precisely. By enabling Foundry Local to run massive multimodal AI inferencing on local NVIDIA racks with zero internet connection, Microsoft is bringing frontier-level AI capabilities into the most restricted, secure vault environments on the planet. It maintains strict local control while giving these agencies the full advanced capabilities of the Microsoft stack.
What a truly monumental week. Let's just take a breath and summarize the sheer scale of this theme. Over the course of just a few days, we've seen Microsoft simultaneously introduce fully autonomous agents that can navigate user interfaces and terminals, launch the custom silicon required to run those agents efficiently, and build the offline vaults and DLP kill switches required to secure them.
It's a lot to take in.
We've gone from breakthroughs in AI memory retention with the EMPO framework to workflow automation with Grok, all the way to entirely new business models with the premium E7 suite. So we ask you, the listener, as you look at all these moving parts, what stands out to you?
For me, it's the rapid, undeniable convergence of all these technologies. This isn't just a software uptick cycle or a new chip announcement. It is a totally integrated, closed-loop ecosystem being built in real time.
Exactly. The pieces are all locking together. I want to leave you with a final provocative thought to mull over today. We are clearly seeing AI transition from a mere helpful tool to an active digital employee. We just discussed the data showing that senior engineers are currently spending highly valuable time mentoring junior developers on how to fix the sloppy, intern-level mistakes of these AI agents.
Right.
But what happens in 5 years? When those AI agents become advanced enough that they're the ones tasked with training the next generation of junior human developers, will our future code base and the humans who maintain it inherently inherit the machine's hidden blind spots?
That is a fascinating question.
It is something to seriously chew on as we cross the threshold into this new autonomous era. Thank you so much for joining us for this deep dive. We really appreciate your time, and we hope you walk away today feeling thoroughly informed and ready for what's next. Keep exploring, keep questioning, and we will catch you next time.